Assalamualaikum and greeting everyone. Welcome to my final year project presentation. My name is Hayati binti Abdullah, a final year student in Bachelor of Science Honours Biology. The title of my FYP project is Green Synthesis of Silver Nanoparticles using Senduduk Melastoma Malabatricum Leaf Extract Characterization and Antibacterial Activity. My supervisor in this project is Dr. Nomaisarah binti Sarizan. Table of content. There are 5 chapters that will be discussed in this video, which is Introduction, Literature Review, Methodology, Result and Discussion, lastly, Conclusion and Recommendation. In this era, discoveries in nanoscience and nanotechnologies have made life easier practically in every aspect of life. Nanotechnology is the most dynamic field of material science research involving the design, synthesis and manipulation of particle structures with sizes ranging from 1 to 100 nanometers, which is known as the nanoparticles. The unique characteristics of nanoparticles have enabled them to play a significant role in biomedicine, energy science, optics, and others related applications. Silver nanoparticles have gained particular interest among noble metals nanoparticles due to their unique features, which include good electrical conductivity, chemical stability, and catalytic and antibacterial activity. The plant of interest for this research is Melastoma malabatricum, or also known as Senduduk. In this study, malabatricum leaf will undergo extraction to conduct green synthesis of silver nanoparticles in an eco-friendly, economical, and more effective approach, as well as to study their antibacterial activity against bacteria for growth inhibition properties. Problem of statement. Antimicrobial resistance have become a worldwide threat to public health in recent years, and the discovery of new medicinal plants could give a simple solution to the problem. Plant-based antimicrobials has become source of medications with significant therapeutic potential. They have been used to treat infections effectively while avoiding many of the negative side effects associated with synthetic antimicrobial drugs. Throughout time, some pathogenic microorganisms have developed resistance to a variety of commercially produced therapeutic antimicrobial treatments. As a result, both commercially manufactured medicinal and synthetic or conventional antimicrobial agents must improve their antibacterial activity. The use of chemicals in the manufacture of medicines can give a negative impact in several aspects. Chemical-based nanoparticles manufacturing is vastly expensive and harmful to the environment. There are 3 significant of study in this research. First, information. This study could provide information and knowledge on the green synthesis technique of silver nanoparticles using extract of Senduduk Melastoma malabatricum leaf. Second, awareness. This study can create awareness to people about the benefit of using plant extract for the synthesis of silver nanoparticles as plant extract, which is efficient, cost-effective, and safeguarding human health and the environment, resulting in less waste and safer goods. Lastly, environment. The plant extract serves as both a reducing and a capping agent. This environmentally friendly technology could be a sustainable alternative to physical and chemical methods for silver nanoparticle synthesis, as the method involves the use of lethal chemicals that can lead to a chemical contamination. There are 2 objectives of this study. First, to biosynthesis and characterize the silver nanoparticles synthesized from Senduduk Melastoma malabatricum leaf extract. Second, to determine the antibacterial activity of silver nanoparticles synthesized using malabatricum leaf extract. What is Melastoma malabatricum? Melastoma malabatricum is a flowering plant native to Southeast Asia, particularly Malaysia. It's a little tree or shrub with a reddish stem and small scales that grows up to 5 meters tall. The color of melastoma flowers varies from pink, mauve to purple, violet, and occasionally white. And the flowers are only available for 1 day. The fruits have an uneven shape and many seeds. When the fruits are ripe, they crack open irregularly to show the velvety, dark purple, sweet but astringent tasting pulp and many orange seeds. The leaves are green in color, have a rough texture, and coated with tiny hairs. The leaves are large-shaped and bristly on the underside. Now, let's move on to chemical composition of malabatricum. Scholars have isolated and identified 142 chemicals from various parts of malabatricum, which include flavonoids, tannins, phenylpropanoids, organic acids, ester, tryptophanate, steroids, and others. Previous study mentioned that amyloid-biotrical leaf have a higher concentration of flavonoids and tannins than other parts of the plant, which may explain why leaves are the most used part in traditional medicine. Next, previous study by Daladi had carried out phytochemical screening as well as total phenolic and flavonoid content studies of methanolic extract from various sections of amyloid-biotricum. Their study showed that tannins, steroids, phenols, and flavonoids were found in all portions of this plant during phytochemical testing. Amyloid-biotrical leaf, roots, bark, stems, fruits, and complete sections have been used to cure a variety of diseases in the past, including wounds, diarrhea, skin disorders, and toothache. The first part, which is leaf, are used to cure diarrhea, dysentery, and ulcers, as well as to prevent smallpox scars and treat pugs. The fresh leaf are eaten raw and thought to help with high blood pressure and diabetes. The second important part is roots. In the Philippines, a root decoction is taken to cure dysentery and fever, and in Malaysia, it is used to treat diarrhea. The roots are given to postnatal women to help their men and strengthen their wombs. The next part is fruits. The fruits have been used to treat a variety of oral ailments in Thailand and India, including oral decay, gum disease, and mouth ulcer, and also geographic tongue. Next is flowers. Amyloid-biotrical flowers are also used as a nervous sedative and to treat hemorrhoids. Its flowers, seeds, and leaf are used to treat dyspepsia and also vaginal discharge. Nanoparticles features have led to their uses in a variety of applications. It's come in a variety of shapes, sizes, and structures. It can be spherical, cylindrical, tubular, conical, hollow core, spiral, flat, or irregular in shape, with sizes ranging from 1 nm to 100 nm. Basically, there are three types of nanoparticles, which are organic, inorganic, and carbon-based nanoparticles. In this study, we are focusing on inorganic nanoparticles, which are made up of metals and metal oxide nanoparticles. Aluminium, cadmium, cobalt, copper, gold, iron, lead, silvers, and zinc are some of the most widely used metals for nanoparticle synthesis. The fundamental disadvantage of chemical and physical procedures for forming civil nanoparticles is that they are extremely expensive and involve the use of poisonous, hazardous substances as well as potential environmental and biological risks. Civil nanoparticles can be incorporated into a wide range of applications. The example is like catheters, nanocrystalline dressing, bioimaging, coating paint, cosmetic, coated paper for food packaging, and so on. The experimental design was started with sample collection, preparation, and extraction. Fresh and healthy leaf of amyloid-biotricum were first cleaned. Next, the leaf were air dried at room temperature for 1 week. After dried, leaf were grinded into powder. Then, the amyloid-biotricum leaf were extracted by maceration technique. 20 grams of fine powder of leaf were mixed with methanol for 3 days. Next, the extract was filtered 3 times through Rackman filter paper. Then, the extract solution was evaporated to dry using hot plate magnetic stirrer. Last, the concentrated crude extract of amyloid-biotrical leaf was kept in the 4°C chiller until further use. For the characterization of synthesis civil nanoparticles, the production of amyloid-biotricum civil nanoparticles were investigated using UV visible spectroscopy, which offers information on the size, structure, stability, and clustering of the nanoparticles. The progress of the reaction between meta-ion and this leaf extract were monitored by UV visible spectra at different wavelengths in nanometer from 300 to 800 nanometer. There are 4 steps that we use to conduct antibacterial assay, which is preparation of myelinated agar, preparation of nutrient broth, preparation of inoculum, and distribution test. For the result of percentage yield of 20 grams of amyloid-biotrical leaf was 6.30%. Increasing sample weight will result in higher percentage yield of produced crude extract based on collected value. Next, the production of amyloid-biotrical civil nanoparticles is the color of the solution gradually change from light yellow to dark brown after 24 hours, therefore indicating the formation of civil nanoparticles after 72 hours. For the result of UV visible spectral analysis of amyloid-biotricum civil nanoparticles, the characterization of synthesis civil nanoparticles based on SPR vibration was observed at 421 nanometers that confirmed the synthesis of civil nanoparticles using amyloid-biotrical leaf extract. Next, for FTIR analysis, FTIR absorption peaks were observed around 3300.50, 2117.63, 1638.42, 1012.13, 949.88, and 662.05. The result of FTRI analysis confirmed the presence of amine, alkyne, amide, alcohol, and alkyl halide that bounded along civil nanoparticles. Lastly, the result for SEM analysis of aminobatricum civil nanoparticles, the scanning electron micrograph revealed that spherical morphology of the civil nanoparticle synthesis with aminobatricum leaf extract at nanoscale size range not more than 100 nanometer, which confirmed the formation of civil nanoparticles. The antibacterial was compared at 3 different concentrations, which are 50%, 75%, and 100% of aminobatricum civil nanoparticles. From this finding, it may be concluded that synthesis civil nanoparticles from pseudodot leaf exhibit broad spectral activity to inhibit both gram-positive and gram-negative bacteria at 100% concentration of aminobatricum civil nanoparticle solution. As a conclusion, civil nanoparticles were successfully synthesized from pseudodot Melastoma malabatricum leaf extract as a reducing and capping agent. The reduction of silver nitrate was visually confirmed by the change of color from light yellow to dark brown. The spherical shape of civil nanoparticles with nanoscale size were observed from SEM analysis. Synthesis of malabatricum civil nanoparticles have antibacterial action against both gram-negative and gram-negative bacteria. And malabatricum civil nanoparticles antibacterial action shown a potent bactericidal impact. Its property may be proved to be well suited for use in pharmaceutical and other biological application in the future. For the recommendation, further studies should be more focused on each part of the plant, for example like stem, fruits and roots of Melastoma malabatricum. The research can do phytochemical screening that can help in searching for bioactive agents that can be found in the synthesis of useful drugs. For these studies, only one biological activity was tested. However, more biological activities may be tested in the future. In addition to antioxidant activity, future tests on the plants may include measurements of total phenolic compounds or ferric reducing antioxidant assay. And lastly, in order to gain the benefit, the medicinal plant needs to be continually tested for further study. I end my presentation with the list of references that have been used in my research paper. That's all from me. Thank you for watching and listening.